Very good. Welcome, everybody, and thank you for attending this initial meeting of the Polar Technology Community. The order of events for today is that we're going to have a presentation by Michael Pryor-Jones from Cardiff University on solar regulators, how to stop them sucking the life out of your polar instrumentation. Always nice to have a catchy title. And then after that, and then we'll have a discussion time as well after Michael's talk. And then I'll take over and give a presentation on the Polar Technology Conference 2020, as well as how that has evolved into the Polar Technology community. And then Jonathan Blythe is going to give a 5-minute little presentation on IARPC's future technology foundational activity. And then we're going to leave at the end like 15 to 20 minutes for really community discussion that we're able to pull together and get more feedback in terms of what you as a community feel we should be going in this direction. So with that, I hand it off to Mike.
Thank you, Mark. I will just get my slides going. And yeah, that's good. Okay, so good morning from Cambridge in the UK. I work for, slightly confusingly, I work for Cardiff University, the other side of the UK, if you're familiar with our geography, but I work remotely from home. I'm going to talk to you today about solar regulators. I just wanted to acknowledge some help I've had from a number of colleagues, particularly Liz Bagshaw, my colleague in Cardiff, but also from 3 very experienced American engineers, Thomas Nyland, now at DTU in Denmark, Joe Pettit at UNAVCO, and Paul Carpenter, and they contributed data and insight into this piece of work. So I'm hoping in this community, lots of people will be familiar with the idea of using solar powered instrumentation in the polar regions. I've just picked 3 examples here. The one on the left with the guy in the orange jumpsuit is a low powered magnetometer in Antarctica. The 2 pictures on the right are from a field camp. This is one of Antarctic Logistics and Expeditions field camps a few years ago. And we have solar panels here shot in the glorious polar summer, making lots of energy to power instrumentation and equipment. And this is, kind of the default way we do things now. And we end up with a fairly simple system design. We're trying to take power from the solar panel and store it in a battery. And in almost all cases, this is a lead acid battery, like the one I've pictured here. But there is a problem. If we just wire the panel to the battery, firstly, the big problem is that when the sun's no longer shining, when it goes dark, the panel actually acts as a simple diode and will discharge the battery and the panel will get hot. And that's not what we want. And the other problem is, particularly in the polar summer, with 24-hour daylight, there's the possibility that you can overcharge the battery with continuous daylight. The battery will top up to the point where it's receiving more charge than it can really cope with, and you run the risk of a fire or of an electrolyte leak or something like that. So for all these reasons, for the most part, we tend to install a solar regulator, and I've pictured one here, popular model in the community made by Morningstar. And the regulator solves exactly those 2 problems. It prevents discharge overnight and it prevents overcharging. And so about a year ago, I was thinking about buying some of these for a system design I was doing. And I put out an appeal on CryoList to see what solar regulators people were using in the community and get some recommendations. And I got a lot of help from people on CryoList. So thank you very much if you contributed to that. And I sent that sort of summary of that back to the community. But one of the things that came out of that was actually looking at how do these things perform in a polar scenario where you are going to have a long period of darkness. And so if I take my Morningstar regulator, which was one of the more popular ones on the CryoList poll, and we're going to take it to a location in the Arctic or Antarctic where we have lots of darkness. I've got a little table here at 70 degrees latitude, you're getting about 50, 55, 53 days of darkness. At 80, you're getting 133 days of darkness. So you really need to be paying attention to how much you are running down the battery during that dark period. And I looked at the data sheets for these regulators, and here's an extract for the one for the Morningstar. And this little line here caught my attention. It says, if you can't read the stat on the slide, it says self-consumption 6 milliamps. And for years, I have to admit, I had naively assumed that that simply meant that when the sun was shining, 6 milliamps of current was used in the regulator to regulate the output. And that's true, but in fact, the regulator consumes that current, this model certainly does, consumes that amount of current all the time, regardless of whether the sun is shining or not. So it's better described as a background current or a quiescent current or a night power consumption or night current consumption. And so this solar regulator, which we bring in to solve our problem, actually, in the dark, it becomes something to be feared. It becomes a vampire that is going to drain our battery and suck the life out of it, because in my case, my instrument only draws 1 milliamp. And if I'm losing 6 milliamps into keeping the regulator happy during the dark period, then I've got a serious problem. So I started to look at some of the other regulators on the market, and I thought, okay, well, let's make some measurements. Just hook them up to a battery via a current meter, and with no solar input, just see how much current they consume. And I did about 14 of these, and I won't present them all, but I've just picked 6 here. Just to give you some extreme examples, the one on the top left is a Canadian one from Eco Energy. And it's quite a small regulator, but its selling point is its extremely low night current, which is 40 microamps, 0.04 of a milliamp. So you can see already, nearly 2 orders of magnitude less than the Morningstar. And then in the middle there, the Genasun GV4 uses a bit more energy, but still far less than some of the others. And the Stecker on the right, the black one, that's a German-made regulator, and it has in fact, that was an interesting one because the data sheet says 4 milliamps, and when I measured it, it was only 2.2. So they clearly specify that quite conservatively. By contrast, the two at the bottom row on the right, made by this company Epeva, which was supplied by my local dealer in solar panels, these both have power consumptions in excess of their data sheet value. So the manufacturer is being economical with the truth about how much these things consume. These are both fairly cheap. And I've used the Landstar in the middle a couple of times and thought, oh yes, that's quite a good regulator, it's very cheap. But actually it's got lights on it, it's got a USB port, it's got various other features. It actually uses a surprisingly large amount of power. So what does this mean in practical terms for someone trying to design a polar instrument setup? So I built a spreadsheet model to essentially calculate the number of minutes of daylight you get every day of the year at a given latitude, using a spreadsheet from NOAA that does that. And then I fed that into a kind of model where we calculate what that does to the battery and what the load is and how much current is used in the regulator. And we calculate the energy change every day. And for these examples, I set this to look at 70 degrees north with a 1 milliamp load current, which is the current consumption of a Campbell CR1000X data logger in a 1 hertz mode. And I assumed a 20-watt solar panel. It's a fairly small setup. And then I then calculated what size of battery do I need to power that setup all through the year reliably, given quite a lot of safety factors for making sure that the thing will keep working even through the darkest months, and adjusted the different regulators to see what size of battery I needed. And the best regulators for this demo system, which were both the Eco Energy one and the Genasun GV4, they only need a 7 amp hour battery, which is pretty small. That's the battery small enough you can take it on an airplane on a regular flight. Not anything particularly special. The Morningstar SG4, which I previously is popular in the community, needs almost more than 5 times as much battery capacity, just because all that energy is being wasted in the regulator. And the worst regulators need more than 100 amp hour battery. So if a bad choice of regulator will result in either you needing a massive battery, or if you didn't allow for it, your instrument dying within a few weeks of the darkness setting in. So I guess my take-home message here is efficient regulators save cost and weight, and it's probably worth looking closely at these regulators and buying a slightly more expensive one to save yourself quite a lot of battery capacity. A few last tips before I go on. not all regulators support recovery from a flat battery. So if you do have the situation where the battery goes flat in the middle of the winter, it is possible with some cheaper models of regulator that the system won't restart because the regulator needs power from the battery to wake up. The better ones will wake up from the solar panel alone and gradually charge the battery. So bear that in mind. I've had some colleagues who design their system to stop working during the winter, and they used a low voltage disconnect circuit. Sometimes you get these built into your solar regulator as well. Sometimes it's a separate unit. If it's a separate unit, do look at it and do look at what its current consumption is, both in on and in off mode, because again, a lot of these are made for the recreational and marine markets where there's reasonable amounts of power floating around, and they're often using similar kinds of up 10 milliamps, sometimes even more, particularly if they use an electromagnetic relay which needs to stay energized. And yes, final reminder, do test everything before you go to a deployment. It is well worth checking that things actually perform how they say on the data sheet. This is the first time I presented these results. I'm actually going to present this at EGU General Assembly with a bit more detail. And I hope to then, I've got a paper in draft with all the details, and with the spreadsheet model will be published along with that hopefully in a few months' time. So thank you very much for your attention, and we have a few minutes for questions, I think.
Very good. Thanks, Mike. So we can do questions from the chat, as well as if you have a question, you can also raise your hand. We can call on you to ask it directly.
Okay, shall I pick up the ones in the chat, Mark, to start?
Perfect.
With? Yeah, okay. So Michael Ellie's asked about the Campbell Scientific CH200. No, I haven't tested that one, but that's one to look at in the future. Jonathan comments, we're interesting to see if we don't have a regulator at all. So that is true, and in fact the Danish weather stations in Greenland, run by the Geological Survey of Denmark and Greenland, GAES for short, they don't use a regulator. They just use a simple blocking diode. And if you have a small solar panel, a very large battery, and a relatively small load, then that does actually work. But I think they just iterated themselves into an optimum solution, and it is a little bit fiddly to make it work. And I would definitely say, from talking to the UNAVCO and Iris Pascal guys who've done a lot of this, that the Genasun is the one that they're currently recommending. It's not super expensive, and it has a load of other useful features on it as well. So it seems to be pretty reliable. So yeah, it's likely that yeah, going down the just using a diode route is probably a false economy.
In your calculations, you did it with just what was it, 0.1 milliamp from the Campbell Scientific. Have you done any calculations if it was like a system that had a larger draw from the batteries and how that would change the size of the batteries involved?
Yeah, it'll all scale up. So I haven't done it particularly because most of my equipment's quite low power. But broadly speaking, if we increase the load capacity, then we have to increase the battery bank. But I guess my point is, make sure that your regulator has an appropriate power consumption relative to your instrument. You want most of your power to be going to the instrument and not wasting power running your regulator. If you're running a big system with a big bank, you're going to end up using, maybe using 10-20 milliamps to keep the regulators running, but that's fine if you're generating, large numbers of amps of current to power your instrument.
Okay.
See a question from Liban Loke. What at the component level gives rise to the self-consumption current? Good question, Liban. And it would be, I don't know a lot about the topology of these regulators. My suspicion is that the older designs, particularly like the Morningstar that I mentioned, that product's been on the market for a long time, and I think that probably has some fairly unsophisticated analog electronics in it, and there's probably some bipolar transistors being biased and that kind of thing that's using that, producing that self-consumption current. I think a lot of the newer ones have got modern microcontrollers in with very low power consumption, and so that's a lot easier.
All right, any other questions? All right, so we're gonna shift now to my presentation. I'm gonna, hold on. Looks like, all right, hold on, let's see, share screen. All right. Something just, okay. So thank you again for coming to this meeting, and thank you for this opportunity to share about Polar Technology Conference from 2020 and our future vision and activities for the polar technology community. This presentation was put together with the assistance of Nancy French of Michigan Tech, as well as I'd like to acknowledge the other members of the PDC 2020 Organizing Committee as listed on this slide and in our photo from the PDC 2020. The PDC initiated out of informal gatherings at Stanford University in the early 2000s. These informal gatherings shifted to formal meetings, which was referred to as the Polar Technology Conference, and were held annually from 2005 to 2016. These are meetings of technicians, engineers, field personnel to discuss, troubleshoot, and share lessons learned from the application technology in the polar regions. These meetings also relied on volunteers and participating institutions to organize and host. The first two meetings were held in California, and then the PDC was held at 9 different locations from 2007 to 2016. However, with the increased load of both the volunteers as well as the hosting organization, the planning for the 2017 meeting was delayed and then went on hiatus due to the need for a dedicated funding source and planning team. That brings us to the Polar Technology Conference 2020. NSF OPP provided funding to restart the PDC. They tasked ARCIS to provide the administrative support to organize it and to host it, with the goal to link experts in polar science and technology and development from across a spectrum of fields, including academia, government, industry, support contractors, and the military. The disciplines that were involved include terrestrial, marine, atmospheric science, social sciences, and some biosciences, and all levels of logistical support. With this, we unified these range of disciplines by the commonality of working in the polar regions, as well as by focusing on areas of common interest among the groups. The PDC 2020 was held the 10th to 12th of March, 2020 at the University of Colorado Boulder. And if you have a good recollection of dates, you'll also recall that that was right as the country was shutting down due to COVID-19. In fact, the next day, the CU Boulder campus was closed and would not open to the public again for a year and a half. There were 82 in-person attendees, 103 online attendees. Then there were 29 cancellations due to COVID-19 travel restrictions. The conference was formatted around 6 themes or areas of common needs of interest. These are science drivers, power systems, instrumentation, communications, data access and sharing, then overarching and integrative technologies. I highlight the middle 4 here as these are the 4 that really applied across the range of disciplines. The concept is that no matter if you're a terrestrial scientist, geophysicist, atmospheric scientist, biologist, and so on, there are common needs when it comes to data communication, data communications, power supplies, and so on. For each of these themes, we had a keynote presentation, 2 oral presentations, and then a panel session from those that spoke, followed by, we also had a poster session during the PDC 2020, which were covered topics from all of the different themes. In addition to the general sessions, we had a peer coaching session on the first day. In this peer coaching session, we had groups of 8 to 10 participants to address polar challenges. And how it worked is that all of the participants in a group were given the opportunity to share a polar technology challenge in their own work, then receive guidance and problem-solving suggestions as a collective group. We also held a special session on satellite communication with in the registrations. We caught a lot of high interest in this area, so we held a special panel session just dealing with satellite communications. The lessons learned from the PTC 2020 was that the return was met with enthusiasm. People were happy to and excited to be speaking with their colleagues again and to hear what has been working and what has not been working. There's a strong interest in pooling ideas and experiences from experts in applying technology in the polar regions, focusing on common areas, power system comms, allowed us to expand the discussion across the disciplines, as well as there is appreciation and interest in keeping up, including novel approaches to discussions to broaden the ideas and input that could be shared in the community. We also felt that partnering with industry at all levels provided great opportunity for targeting advancements in technology, both for industry to learn more what the community needed, as well as for the community to learn what industry is able to provide. We had industry set up vendor tables, as well as a short chance to introduce themselves to the larger group, and as well as opportunities for industry to talk directly to the users of the technology in the polar regions. From these lessons learned in the months following PTC 2020, we understood that there was a desire to provide year-round opportunities to engage the community and to facilitate ongoing exchange of ideas, information, and experiences. With this desire to have a year-round ongoing community, as well as the strong appreciation and affinity for the PTC acronym, we chose to rebrand the Polar Technology Conference to the Polar Technology Community to reflect year-round participation and activities. Throughout this, the goal is to bring common stakeholders together to share experiences and ideas of the application of technology in the polar regions. So what does this vision look like? We want to engage and facilitate ideas and experiences across what we've defined as a three-part community. This three-part community is practitioners, which are scientists and field support personnel, science and technology developers, those that sort of bridge the gap between the latest and the greatest in the technology world, and which can work in the polar regions, and then industry and vendors, which can provide solutions across multiple groups, provide commercial off-the-shelf systems, as well as to lower the cost and increase the efficiency of the products. We want to exchange information of solutions across these three-part community in exchanging what's been successful as well as unsuccessful when deployed in the polar regions. We want to serve as a resource to provide guidance to industry and technology developers on polar community needs. We are not as much doing science nor developing new technologies as it is a networking organization specific to the advancement of polar science. The vision continues with the stakeholders in academia, government, field support, industry, and military, covering both polar regions, the Arctic and the Antarctic, as well as seeking international collaborators, such as Michael Pryor-Jones, in providing input outside of the US for other Arctic and Antarctic programs, leveraging their experience and knowledge. For the PTC 2020, we had registrants from China, Russia, United Kingdom, New Zealand, and Denmark, all of which not all, but pretty close to all of which were not able to attend because of COVID-19 travel restrictions kicking in. We want to focus on common applications, instrumentation, power system, comms, data access sharing, field support infrastructure. The activities for the PT community as currently envisioned include in-person workshops. And so these are the old Polar Technology Conferences held approximately every 18 to 24 months, held in September or March, bridging that field season between the Arctic and the Antarctic, with a traditional oral and poster session, panel discussions, breakout groups, but also including peer coaching sessions. Another idea of peer coaching that was provided was to have small group discussions on half-baked ideas where participants throw out ideas to be incubated and discussed among the groups, as well as half-day training sessions on common needs. So for example, we could have a training session on best practices in designing and building power systems, or best practices in communication systems, or a training session by the Polar Geospatial Center on resources and data access that they can provide for people in the field. Then also we want to keep that tight integration of industry and vendors to the workshop. So that's sort of continuing what has been in the past. The new ideas that we want to explore and enact include quarterly webinars, which are 2 presentations in a 1-hour time slot with questions and discussion, which was Michael's presentation, which was a well-done example of those presentations we want to engage in. And then a community online forum. And this forum can be like an online exchange of questions, ideas, issues, and solutions amongst the community. You can think about it along the lines of like a Stack Exchange as well, where people are able to rate different solutions. The idea there is that when somebody's working on a new project, they don't have the opportunity to wait for the next workshop. Instead, provide a forum where they can ask their questions or issues. A couple ideas that have been formulated in the last couple of days with the National Academies workshop is to create a wiki of best practices and guidance. And we'll actually see in the discussion time, one of the people at this meeting has already started to create a skeleton of what that wiki would look like. It would be an aggregated and curated source of referencing designs and recommendations from experienced members of the community. Another even less defined idea is a repository of engineering and technology used in the polar regions. Exactly how that repository would work is completely wide open. And then lastly, journal special issue coordination on applying polar technology in the fields. So as a summary, the Polar Technology Conference is now the Polar Technology Community, maintaining the PTC acronym. Technology Resources Group forum built for and by polar research scientists and technologists, focus on Arctic and Antarctic needs for cutting edge solutions in unusual settings. And as has been covered before, we invite any and all polar scientists, technology experts, industry developers to join the PTC as we build and define a community for your needs. To acknowledge the funding again, PTC 2020 was funding for that was provided by NSF OPP. The Polar Technology Conference, all the materials from that are provided on ARPC's website. And with that, Lisa's provided that link in the chat. And then we have this Polar Technology Community self-forming team. And also feel free to contact me with any questions. So before we get into discussion on this, because it dovetails into the overall discussion, we are now going to switch to a presentation by Jonathan Blythe to see the IARPC vision with the technology foundational team.
Thanks, Mark. I appreciate the history and background for the Polar Technology Conference and community. And I noted at the 2020 meeting there was they decided to move to the community to the IARPC forum, and I was not involved at that time, so I don't know what the circumstances were and what the cause for the delay was, but I could just speculate based on the timing of COVID and all. But now we're very attuned to the virtual environment, and this is the space in which IARPC operates. It has a number of collaboration teams. I have experience working with a data collaboration team over the past few years, and it was during the release of the new 5-year plan for IARPC where the United States states its research priorities and objectives, and that I saw an opportunity to step into this role for the technology team. The team was initially proposed as a self-forming team, but as it stands, IARPC's moving away from its old organization structure. So the website will be undergoing some major changes, and I know Liz will probably be able to speak to that if anybody has questions. But the collaboration teams will continue under the new 5-year plan. However, there will be another series of teams that are focused around the policy priority areas, and there are 4 of those that I can't recall off the top of my head. There's also 4 foundational areas, and the technology foundational area dovetails very nicely with this self-forming collaboration team. So my naive thought initially was because we're just starting to have activity here with the polar technology community, and this foundational area is also just beginning to form, that it might make sense to combine them. We're early enough in the process that we don't have a lot of activities or requirements for the foundational activity, so we can be somewhat accommodating to what the polar technology community wants to achieve. And then that would just reduce the number of meetings that we all have to go to stay engaged. There might be some efficiency gains, but I did not want to imply there's like a takeover of one by the other. I don't even have an investment, either way. So I'd probably vote for renaming the foundational team to be the polar technology community, just to make people happy. But that's besides the point. The point is, here's an opportunity to convene people. IARPC is primarily focused on US PIs and research in the US Arctic, but we certainly invite participants from international groups, collaborators. When we want to bring in expertise and learn from developments in other nations, we invite people to participate in the collaboration space. So I think there's plenty of room to incorporate all of the polar technology community's activities. And in particular, I noticed there's some things that we could pull right into the collaboration space that we have, that Liz manages. It's not a wiki per se, but the other one where you just want to send out notifications like, hey, here's a peer review article or something, there's a conference coming up you might want to know about. We can do that right within the IARPC collaboration space. If you want to join IARPC, you can get a membership profile. You put in your details, you put a nice photo of yourself. Now people know how to contact you, but also you assign your user to one of the teams. And by signing up for the notifications from the technology team, you'll automatically get all of this to your inbox. and keep you in the loop on the group's activities. So yeah, so Liz put a plug in there. So I don't think we need to do a walkthrough right now. I did also notice that you're interested in quarterly meetings for this community, and we can do quarterly, we can do monthly. I don't know what the if quarterly is the right tempo. I'd recommend a little more frequently, at least in the beginning, because if you miss a quarter, as you often miss a random meeting from time to time, it'll be 6 months before we hear from people again. So having it maybe every 2 months would be a little better. And then there's some work of the co-leads. We will collaborate on designing the meeting topics, agendas. We always appreciate if people volunteer and give us topics and ideas for presentations, and volunteer to present when we indicate there's something of interest that we'd like to hear more about. So I think keeping the momentum, I'd advocate for us to set up a more frequent meeting, at least for the beginning time, while this team is being established, and the communities, we have our attention for now. And yes, we progress, and maybe in the September timeframe, IARPC will be releasing the biannual implementation plan, which will have the formal objectives and deliverables for the 5-year plan that we can share with the team, and we can kind of do a crosswalk and see how the team meetings that we're planning will address those. Okay, so that's all. I didn't prepare a formal presentation, but I'm glad to have such a dynamic and a large group participate in the meeting today, and I hope we can keep you all engaged in the near future. Thank you.
Very good. Thank you for all that information. Really appreciate it from the IARPC side. I'll address a couple things that you brought up. As one, you commented about how PDC 2020 was over 2 years ago, and this is the first meeting. And you're right, that part of that was COVID zapped out a lot of the initial enthusiasm, as we talked about it like a year later. And one of the comments was people were just zoomed out at the time, and there was less interest to pursue it at that time. But now, as we're getting into more of a new normal, something we could pursue. And the quarterly versus monthly or bi-monthly, we're completely open on that. That was part of the quarterly was gauging how many presentations could we pull together in a year. And so if there's strong community interest in monthly or bi-monthly, that's great. So at this time, actually, for our remaining time here, it's really an open discussion among everybody in terms of questions or comments from my presentation, from Jonathan's comments, and everything in between. You can put questions into the chat, or you can just raise your hand and we'll call on you to speak. I'll also add that if you looked in the chat, the link to the initial skeleton wiki was put in, and you can go to it, and I'll just pull it up here briefly, in that this is ideas of what's been put together. Looks like even more has been added since I last looked at it last night, and this is just a nice way to get ideas going forward from Michael Ashley with this wiki. So I'm done talking and sharing on that. Let's get people going. Ken.
Hi. Thanks for hosting this meeting. I was also attending the National Academy one where the wiki came up over the last 3 days. My name's Ken Mankoff. I'm a scientist at GAIS with the PROMICE Weather Station Network, but I'm actually moving to NSIDC in July. And so I'm looking forward to meeting you then, Mark. I have a concern, I guess, and I apologize because I feel like most of the comments people have at all these meetings are always constructive. And this is more of a concern, which is the wiki. I love what you're doing. I love the idea, but the problem I see, and I hope you have a suggestion for this, is that the traditional way we disseminate knowledge is either publications or workshops / meetings / classrooms, right? One of those two. And the first is incentivized, which probably is why Mike said he was writing a paper at the moment about his little spreadsheet, because it's a career metric. And conferences and workshops are incentivized because we get to travel and network, right? That's what conferences are very much about. But I believe the wiki is the right tool, right? Because it has, of course, some limitations, but it has this incredibly powerful thing that anybody can edit, and it's real time, it can stay up to date, and it's a more casual format. So Mike's paper may not have links to the Amazon URLs where you can buy various regulators, but a wiki could, as just one of many examples. I fundamentally believe it's the right tool. The problem is it's not incentivized. How do you get people to contribute to it when we're all so busy with other stuff and we don't get the career advancement? And so, how many of us actually, even when we run across bugs in our software, go to GitHub and commit bug reports? I do, I'm a computer scientist, but most people don't. And I think that's sort of the level that this wiki is at, which is people may use it if it exists, but we need, the people like Mike, rather than writing a paper, to maintain the wiki and every year update it as new stuff comes out, and then have that be actually something that is valuable for him to do, not just spare time. Otherwise, I worry it grows stale, as wikis often do. Thank you.
Thank you for those comments. And essentially, I would say everything you said is, first of all, valuable in that these ideas are just days old. And so that we need input on how to formulate things and roll it out, as well as, and there was a comment in the chat about, is the initial wiki going to be focused on just Antarctic, or will it expand? And the essential concept on that is expand, in that we're talking something that's days old, and there is no formulation of what this is going to look like. Michael Ashley.
Yes, thanks, Mark. So I put together that initial wiki. It stems from an idea I had at the 2006 PTC meeting in Boulder, actually, where I suggested this. But at the time, I was much more metrics driven in the earlier stages of my career. So I didn't have time to get into it. Now I'm sort of at the tail end of my career. So I do have a bit of time to put into this. And those comments that we just heard were very, very true. I guess the problem is you can't get publishing some of these concepts, some of these ideas. You can't publish them. I mean, no one's going to accept a paper describing how Teflon is a great insulator to use in Antarctica. So I think some of these little lessons that we've learned over the years are not really publishable. So I just thought that a wiki could be a useful place to jot them down, so that incoming new people to the game can learn from decades of experience from the rest of us. Of course, a stale wiki is very common. I don't know how you can avoid that, but some of these ideas I think are useful even if they haven't been updated. So I'd encourage you to have a look at it and contribute. And if you want an account on this particular wiki beyond the next day or so, just let me know. And I hope we can find a home for it and make it work in the future. So thank you.
Great, thank you. Jonathan?
Yeah, I had a couple of thoughts on that those comments also brought to my mind. I mean, I remember seeing in my graduate school department, some of the more senior scientists, they were, I'm an oceanographer by training, and they were doing a 50-year prospectus on plankton net design. You know, they'd been through all these different permutations and changes, you know, with advent in technology, and that ended up as like a tome that was published, and at the time it was paper publishing in the Journal of Oceanography. And so I think there's, if you find the right outlet, that this can be a published product. But you know, we obviously live in a different era now, and you know, publishing a static document's not necessarily the unless you're just looking at the history of things, that would be a perfectly fine outlet for that. But if you wanted to be an outlet for bringing people up to speed to current and maybe even future developments, then that's where a dynamic platform like a wiki would be really useful. So yeah, I don't know, Liz, is there a capability within IARPC to be hosting a wiki and to be providing some of the more, you know, support to make it available and integrated with the IARPC collaboration forum?
At this point, there's not a like wiki-esque platform. We could definitely explore it, and if nothing else, could be, you know, there could be frequent posts to IARPC collaborations reminding people to edit it. But yeah, there's not a built-in wiki feature.
Right. See, I think there would be some value of making sure it was integrated with the community. Somehow, by, you know, by the very nature that the community is active, the wiki would remain updated to some extent.
Yeah, it's something that if this team wanted to really go down that route, we could talk about ways to maybe integrate it. But at the moment, it's not something built into the system. And yeah, I think seeing in the chat, I think it's important to have at least someone whose job it is to administer it.
All right. Just because this is all new ideas and there's different directions we can go. Mike, can I call on you to expand on your comment in the chat? Or to introduce your comment in the chat?
Sorry,
Sure.
which mic are you talking to? Several mics.
Yeah, the one with the longer post, you. Michael Pryor Jones.
Sorry, yeah, sorry, because Michael Lilly's got his hand up, but I'll just install it briefly. I'm just going to say that I've experienced a lot of wikis, and I've seen a lot of, hey, this is the engineer's solution to write documentation. Let's have a wiki. It's easy, and I think doing a small wiki basically requires somebody to curate it and keep it up to date, because as Ken says, it's wonderful if it can be kept up to date, but in practice, even within a business where I've worked before and we've used wikis as internal documentation, very rarely are people incentivized to keep stuff up to date, and it just, you know, you can, and links go stale, information gets out of date, you end up with a half-written thing which contains some information that's still relevant and some information that's stale. And I think my preference has been for a light touch publication system where people write a short note, a technical note, which could be in, you know, just 1 or 2 pages, and it gets a date and an author, and you know who wrote it and when they wrote it, so that information, when you look at it in the past, you're like, okay, that's ancient history and that's out of date, or it's of historical interest, or maybe that's still relevant, but you can make that decision and you can contact the people that were involved in a straightforward way. And I think there's a lot of nice technology around how preprint servers work, for example, that could be repurposed to make this kind of light touch publication system and an indexing system to help people find things, rather than necessarily going down the wiki route. The other thought I had is that we are starting to see people do diamond open access journals, which are ones which are free to publish in and free to read. And that's also quite a nice model if we can find somebody to cover the cost of running the platform and the basic editorial aspect of it. You know, there's no reason that journals have to be stuffy. you know, as Michael Ashley's saying, you know, this stuff, nobody will publish this stuff. Well, we can if we're the journal. So yeah, that would be another approach.
Great, thanks. Michael Lilly?
A lot of good comments on the wiki site. The U.S. Permafrost Association has been running one for 20 years. So we've experienced every comment that's been given. And I think there's solutions to that. I think the comments that Mike Pryor just made are really valid. You need a variety of different tools in your toolbox. Wiki is just one of those. And whenever you go in the field with one tool, you're always never prepared. So I wouldn't discount the wikis, but I wouldn't say that's the end all for everything. And we're certainly happy to take what we've learned from USPA and help this group with what they want to do. Over.
Great, thank you. Any other comments or discussions on topics beyond the wiki with what was presented with the Polar Technology Community and IARPC? All right, with no further, oh, Nancy?
We pulled the trigger at the same time. Just a quick comment. Glad to be involved and see this moving forward. I want to say thanks to Mike Pryor Jones. That was a good example of what I think we had in mind when we were thinking about this stuff. And just a comment on the quarterly versus monthly meeting idea. When we were thinking about this, it really was in a way, those meetings were simply a continuation of the conference. So people who can't get to the conference could have a virtual way of getting their information and present stuff. Now that it's got a little bit of legs, I think monthly could be a good meeting cadence. I would say that it's going to be hard to find if the content is simply people bringing their hour-long or 40-minute long presentations. It could be, you know, a bit difficult to find people to present. So that's why I think we were going with the quarterly. I think if we think about what we have for meeting content, what are we going to be doing at the meetings? Then we can, I think a little better about whether it'd be a monthly or a quarterly. And so getting to that, maybe we do need monthly at the beginning just to discuss what we're going to discuss. What are the meetings for, and how are we going to structure the organization? It might be good to start out with that more often, and make a decision on a more permanent basis. See how the wiki's going, things like that. So that's just my comments. Glad to be involved.
Great, thank you. All right, now we'll go for last call of any other comments or questions. Jennifer. Jen.
Hi, I'm sorry to have joined late, but I'm really grateful to be able to join. I'm wondering, you know, I saw Michael Lilly's comment about short 10 to 15 minute presentations would be helpful. I'm wondering what else would be helpful, and I apologize if you're having to repeat this. But what are you looking for from folks now? Thanks.
In terms of the quarterly meetings, or
just in general? So
yes.
This last workshop was my first to attend, and so I'm just looking for input on what's going to be useful.
Yeah, sure. And we're looking at the quarterly, monthly, or bi-monthly meetings, as well as then providing the resources such as the wiki that was discussed for a little while in these questions, as well as just exploring ways to establish communication amongst the community members to really have an ongoing discussion. So that's the main focus of what we're looking at.
Great. Thank you, Mark.
All right. With that, we're approaching the top of the hour, so I will end this meeting. Thank you, everybody, for attending. Feel free to spread the word, and we'll be getting messages out. We'll just say in the near future as far as when we'll be convening again. So thank you, everybody.
Thanks, everyone. And the recording of this meeting will be on the IARPC YouTube and on the event page probably later today.
Great. Thank you, Liz.
Yep. Thanks,
Bye-bye.
everyone.
Thank you.